Spell it.
SQL.
SQL. SQL.
SQL.
Okay. Is that all? No other pronunciation?
Is it SQL?
SQL. Good, I'm waiting
SQL.
for that one.
SQL.
SQL.
Is it as pronouncing like that?
Exactly.
All right, so the thing is, it's so beautiful that people give it different names. People pronounce it their own way, and it is still correct. You can pronounce it SQL. 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 You can just give it any name. It will respond because that's actually how sweet the language is. It usually responds. It usually responds. So, welcome to today's class on SQL. Do you have your tools ready? Open your SSMS. It's going to be hands-on. Open your SSMS, everyone. If you don't have SSMS, open your MySQL. Everyone, please. Everyone, please open it right away. You'll have like 3 minutes to open it because I know it's heavy. So if you have MySQL, you want to open, what you will be typing is workbench. MySQL workbench. It is the equivalent of SSMS. It is the equivalent of SSMS. Are we all there?
Are you sure I've not downloaded this since
We don't be talking about things downloaded. Because everyone has been guided to do that. We should be talking about downloaded. Oh, I want to believe everyone is on the same page with me. I want to believe we're all on the same page.
I don't think I have this on my phone. I'll do it now. It's not a problem. Just download this.
All right. I will tell you when to log in. Are we all there? I'm waiting.
Please, do we have like a link or should I just download anyone? Please, I'm sorry
Yeah,
for
mine is
asking.
not. I don't know. Mine is
Alright.
not coming up.
Let me know whose zone is not coming up. Blessing, you
Yeah.
downloaded MySQL, didn't you?
No, I didn't download that one. I only download. Yeah, I did.
So
Sorry.
it was MySQL. Can you look for workbench? Workbench. Search for it, workbench. You can look, call it MySQL workbench. Who else?
Do you want me to download that?
You should have installed it. That's what you installed.
Yeah, because I can't see workbench on this.
Search. Go to your search.
Go to your search and search for it. Workbench.
Yeah, it's asking because he said SQL server, server type, server name. Not requesting for login.
Yes, when you create it. Did I hear SQL Server, which means you're not using your Mac, you're using your Windows.
No, I'm using window, yeah.
So it's SQL Server you installed then. It's those with Mac that would have installed Mac and MySQL, since there is no Microsoft does not have support for Mac OS.
So does it
Mac
mean
OS
I've
support.
downloaded the wrong one then on
Actually downloaded this SQL Server. So can you look for SSMS? Who else has challenge, please?
and even that SSMS, I think I downloaded that
Sorry,
one.
I don't know what to say, but
Who?
sorry for that.
Who?
This is Vincent.
Vincent. All right,
I don't
so
even
I
if I
heard
have
you already have it, so you didn't need to install it. I think that was what the feel that I got from you or from the group. I don't know.
like I don't have SQL. What I have is my PHP admin.
Oh, you have PHP my admin.
Yeah,
All right, so that's fine. You to access
but I want to.
PHP my admin, I will recommend, since it's PHP my admin is MySQL. So I will recommend you install MySQL Workbench. It's the SSMS version of SQL Server. So please, going forward, you can install it. All right, so let's move on. I
So
believe
what I'm using is I'm using Windows.
yes, you can when you have the time you can install SQL Server and SSMS. So SQL Server is the database engine. SMS is what you use, what's the interface you use to query databases.
Okay.
Please, I have a challenge.
All right, go ahead and ask. What is the challenge?
So, what are we opening MySQL Server Management Studio, or should we go to the
No.
installation?
So you're opening SQL Server Management Studio, which you installed before now.
Okay. Where it's
My
showing maybe put your password or something.
Oh yeah, you should. If you installed it, then you should have it. Type SSMS on your window on your search. Then, if you click here, you click the window icon, type SSMS, and then you should be good to go. And you will see SSMS. Then open it. Now SSMS is the same thing for SQL Server. Please ensure you're right, because classes have started. It's not going to be the conventional one. Classes have started. SSMS is to SQL
Please,
Server.
we are still
Get,
struggling. I
get
can't
your
see,
notes,
please.
please. Get your notes, please, so you don't miss out. This is a follow-up. This is a class we're supposed to have yesterday. It's important you get your notes, please. Grab your notes by your side. Grab your notes by your side. This will help you, trust me.
Hello?
SSMS, Joshua, and every other person, please grab your note to your side and write.
Yeah, but I haven't opened it yet.
Grab your
To the
note. We
lecture.
cannot wait again for you to open it, Joshua. That's why we dedicated a whole class for installation. We can do that later. So let's move on with classes. So please grab your notes so you don't miss out and write. I encourage you to write. Please, everyone write. SSMS, it could just be, it doesn't have to be the conventional note copying method. It could be things you just, important facts that will, when you look at it, you will remember a lot of what you have learned. SSMS is to SQL Server what workbench is to MySQL. And I will show you the both of them in the course of this class. This is a database engine. This is the database engine. This is the database engine. MySQL server, whereas this is the GUI. So instead of you going to write your code in an environment that is not friendly, like the user, like the command prompt, you come here and write the code. While the application is heavy, but it does the job. So that's why you're recommended to use a high-end system. So GUI stands for Graphics User Interface. So SSMS is the Graphics User Interface for SQL Server. Workbench is the Graphics User Interface for MySQL. That's what it is. And let's move on. All right. So what is SQL? It's going to be interactive class, and I'm going to be asking questions. I will start with someone I feel has an idea. Vincent, in 30 seconds, tell us what you think SQL is in your own words. 30 seconds, please.
SQL stands for Structured Query Language. Is the standard programming language for designing, manipulating relational database.
All right, excellent. Thank you so much, Vincent. That's beautiful. All right, so Fatima, in your own time, 30 seconds, tell me what you think SQL is or SQL is.
Okay.
I understand this for storing and processing information in database, relational database.
So,
All right, Fatima, I'm not sure I heard you well, but if you're not talking, you mute yourself.
You hear me?
All right, I can hear you now. Just
Okay,
only mute yourself.
okay. I said I understand it is used for storing and processing information in database, relational database.
All right. All right, that's fine. That's good. Abies, 30 seconds. SQL. Abies, unmute and talk, please. SQL.
Sorry, I thought I was unmuted. SQL, structured query language, is used to access and manipulate database.
All right, thank you so much. Good answers, everyone. So it means we have an idea of what SQL is. So let's dive deep into SQL. SQL, as the word stands, is structured query language. Structured query language. Now, let's no one ask you that silly question they will ask. Is SQL a programming language? Now you can see that it's a language. But it is the language for databases. And it's not the language for all the databases. It is the language for relational databases. Relational databases. Because we have databases that are not relational. And when we talk about relational database, it comes to this point, structured. When we say structured, we mean databases that are in table format. In databases that are in table formats. So they are structured. And because they are structured, they are rigid. They are rigid. So they are not as robust as the non-relational database, which we call NoSQL. So some people will call it, another version of this, some people will call it not only SQL. Some would interpret it as no SQL, like completely no SQL. And that's because there is another version of database we call semi-structured. Semi-structured database. So, but in this course, we will be learning structured database. That is what SQL is. Again, I will explain again. SQL stands for Structured Query Language. And this language is the main language approved by ANSI for relational databases. And when we talk about relational database, we're talking about structured data. And what do we mean by structured data? We say data that are represented in tables, in table format, with rows and columns. Rows are what you see are these cells from left to right. Columns are from top to bottom. So what we have here is 1, 2, 3, 4, 4 rows. That's what we have here. 4 rows. Whereas what we have here is 3 columns. So please take note of this. So SQL is a programming language designed for managing and manipulating relational databases. It enables users to interact with databases by performing tasks such as querying data, updating records, defining database structure, and many more. Like there are so many things SQL can do for you. SQL is an ANSI standard. SQL is an ANSI standard. So what it means is that this is the standard by this organization for us to query databases. And this stands for American National Standards Institute. American National Standard Institute. It is, that's why you heard the word ANSI SQL. SQL. Because we're talking about the generic SQL, ANSI SQL. It is the foundation upon which other SQL dialect or flavor were created. And when I mean dialect, I'm talking about SQL Server, So I'm talking about T-SQL, Postgres, MySQL, BigQuery, SQL, and so many other, MariaDB. So this is the standard, and every SQL language has a standard they must maintain to be able to be called SQL language or SQL. So, like I explained, SQL can execute data, can execute query against database. It's actually the main language for database, querying database. It can execute query against database. It can retrieve data from a database, like getting data. Retrieve. It can retrieve data from a database. That's wrong spelling, if that's the correct one. SQL can also insert data. That is, add data to a table, or add data, yes, add data, yes, insert data or record to a database. SQL can update the existing record. SQL can update the existing record. Now I'm heading somewhere with this. SQL can delete. SQL can delete data from a database. Of course, SQL can create data from a database. SQL can create new table. SQL can create stored procedure in a database. SQL can create views in a database, and all these things we will do then. Now, where am I driving at? In a normal software development, that is what we call CRUD application. It's what we call CRUD. Or in HTTP, there's also what we call CRUD. CRUD stands for create, read. So this read is the same thing as retrieve. The R does not stand for retrieve, it stands for read. So for the purpose of this teaching, I will take retrieve. U stands for updates. It stands for delete. Now, this is the typical thing a software engineer does in every application they build. You either read, create, update, or delete. And all this, there are other ones anyway, but all these things reflect on the database. These things reflect on the database. When you create, you're creating a data on a database. You're reading data on a database, you're updating the database, you're deleting database tables, record. So when you hear about fraud application, all these actions affect the database. And when you're learning database, yes, this is what some of the things you will be doing. But while the data, while the software developer will use what we call an ORM to do their SQL because they try to run away from SQL, you as a data professional must use SQL to query it. And ORM stands for Object Relational Mapper. It makes the life of software developers easy. So, but here there's no such thing like making anybody's life easy. You just have to learn it. So these are some of the things SQL does. Need a new page. All right. So SQL is the standard. But remember that there are different versions of SQL languages. So SQL is the standard, like I told you, but there are different versions of SQL languages. So, and these languages must be in compliance with the ANSI standard. And this ANSI standard, irrespective of the different dialects, this ANSI standard must respect the different dialects must respect the ANSI standard, which are, again, create or insert, update, delete, and select. Again, so as a user, I'll put it this way. As a user, you're querying SQL. And when you're using the SQL, some of the things the language you must, irrespective of the dialect you're using, you cannot change this terms in SQL. You cannot change them. They are standard. Update. Delete. Select. And of course, of all of them, the most popular here. Can someone tell me what the most popular is here?
I think it's select.
All right, that's correct. So select is the one you're going to use the most of all of them. Select is the one you're going to use the most in all of them. So when you're querying your database, you must use them. Irrespective of what you're using, you must use this to query this. You cannot change them irrespective of the dialect you're using. So please take notes. When you're writing SQL queries, SQL is not case sensitive. Not case sensitive. SQL is not case sensitive. So you can use upperlet, just anyhow you want to write it, just make sure the spelling is correct. But it's important you make your work look clean. So SQL is not case sensitive. Please take note of this. It's very important. So you don't think when you're debugging your code is because you started it with capital letter. No, SQL does not care. And that's what is one of the things that is so sweet about SQL. Can someone tell me what this stands for? Can you tell me what it stands for?
Relational database system.
Relational
Relational
database
Relation database management system.
Relational database management system. Please, it's important you control the noise on your background when you are responding, please. It's important. You need to be in charge. All right, relational database management system. And all right, so I'll take another person again. Person, can you give me an example of an RDBMS? are you there?
Are you referring to me?
Blessing.
Okay.
Blessing, can you give me an example of an RDBMS, an example of a relational database management system? Okay, so I take it that Blessing did not hear me. Chidi. Hello.
Yes, Oracle.
Oracle. Oracle is a dialect. It's not fully an RDBMS. It has its RDBMS. Think about it.
Is it?
I need another
My
person.
Is it?
my SQL.
MySQL.
SQL.
MySQL is an example.
SQL.
SQL is a language. SQL is a language. This is a language. What is the, so this is the language, upon what do you write it in? Which, I don't know how to say without saying the answer. All right, so I just go ahead and say the answer. SQL Server is, all right, so let's move on. Now we know what the RDBMS is. Please, as I am talking, you can raise your hands and ask questions, please. Hands and ask questions. All right, so let's move on. So the data, now there are some attributes of an RDBMS. Yes, IBS, ask question, please.
Yeah, when Elo mentioned Oracle, I didn't get what you said after.
So let me explain this. Okay, so I told her that there is a name for it.
Okay.
But so when you're installing Oracle, they usually have different versions. That's where I am coming from. But it does not take away the fact that it is an RDBMS. But when you're installing it, you install the version you need, but it is still an RDBMS, please. So that you don't go and quote me out there that I said it is not an RDBMS. And also, please take note that this SQL we are learning, you're going to be able to use it to write in several RDBMS. You're going to be able to use it to write there. All right, so let's move on. So, some of the properties of an RDBMS. Okay, hello. Hello, go ahead, please. Hello, you raised your hand. Can you talk? Okay. So when you're ready, please let me know. All right, so there are some of the attributes of an RDBMS, of a relational database management system. So the data, one of them is table. So the data in RDBMS in a relational database system is stored in database objects, which are called tables. So a table is a database object. A table is a database object. So the data in an RDBMS is stored in an object, a database object called table. This table is basically a collection of related data entries, and it consists of numerous columns and rows. Like I explained to you earlier, table has lots of rows. In real time scenario, you can be analyzing millions and billions and petabytes of data. So the type of data you will be analyzing out there will be running into millions and billions. The higher the number, the more difficult it is to query. And that is where SQL query optimization comes in. And we are going to also learn how to optimize our query. All right, so if you're not seeing my screen, could you just log out and come in, please? See, you seem like you're the only one who is not seeing my screen. Hello? All right, so let's move on. So a table is the most common and simplest form of data storage in a relational database. So let's talk about, and I've explained what table is. Table is a database object. Let's talk about fields. Please take note of all this. Every table is broken into similar entities called fields. The field in the customer table consists of ID, name, age, address, salary. So we actually worked on user stories, and we talked about some of the columns the table we actually worked on should contain. And these columns are called attributes. They are called fields. Please take note of this. Fields. For those who are going deeper in data, features. Attributes. All these things mean the same thing. They all mean the same thing. So when I say, how many fields do we have in the table, on the table, you should be able to tell me the number of fields there are. So I'm going to just draw a table here so that you will know what I'm talking about. So you'll be able to relate what I'm talking about. All right, so shapes. Okay, so I'm going to just draw this table. So this is on fields red, differentiate them. Table, we have, can call this ID, can call it this name, salary, position. So when you look at this, these are the attributes. These four things are the attributes. They are the field in a table. And you can also call them column names. So this table has 4 columns. And the name of these columns are this. So you can see another name for it is columns. So you can name them ID, name, salary, and position. So you could call this employee table or your employee table. So in this employee table, these are the attributes it has. All right, so let's move on. If you have any question, please go ahead and ask. So now, what is it about this column, these fields, features, variable? What is it about this? So these are the names used to store. These are the names used to store everybody's record. So these are the names, and then when you come in, like I could come here. My ID is 1. My name is Kingsley. My salary is 10K, and my position is data analyst. I will go here. This is number 2 is Bona. His salary is 10K. His position is software tester. So when you look at it, when I told you that structured database are structured, they are very rigid. So you see, we cannot put any other thing. We just keep putting this information the way it is here. We can actually put a new column, but it becomes difficult to populate it. So in most cases, you keep on adding data the way they are until whenever you want to drop the table. So that's how it is structured. Everyone we have to supply this category, this 4 variable, if their detail would need to be included in there. And while this is variable, field, while this is here, these are called variables, field, features, attributes. This one has a different name, and they are called records. So that's each person's record. They are also called rows. If I go deeper into mathematics, they are called tuples. Ignore this. I have had an interview where this is the only word used to refer to rows in that particular interview. It's because of my knowledge of mathematics that I was able to understand this. Otherwise, I wouldn't have known what it is. And the good thing is I was able to pass that exam. So please take note of this. So a record is also called rows of data, and it is an individual's entry into a particular table. And like I told you, a record is also horizontal. It's written from left to right most times. From the people on the Western world, it's written from left to right. So do we have any question here at this point?
Yes, so
Please.
so
Go ahead.
you said that the rows is called record or tuples. Then are you not saying the column is called variable, fields, features, and attributes?
Yes. You can use any of those names to refer to columns.
Okay, thank you.
Welcome. And it's important we start using those names. All right, so who else? Any other question from anyone? Please go ahead and ask your question. Please go ahead and ask your question. All right, so I'll move on. to the next page. Data integrity. So data integrity has to do with okay, so I'll put it in this way. You must have heard about putting the right data into a system. You must have heard about data accuracy, data consistency, validity of data, validating data. You must have heard about clean data. All these things fall into data integrity. So integrity, it's all about, someone will say, it's saying what you do and doing what you say. That is integrity. Meaning what you actually say. So when you see this data, can you say that this data integrity of this data is preserved? If yes, it means this data is clean, this data is complete, it's accurate, consistent, and you can trust the source. So data integrity is a concept and processes that ensures the accuracy, completeness, consistency, and validity of an organization's data or a company's data. You can also to enhance your data integrity, you need to ensure that there are no duplicate rows in your data. And this is what we call entity integrity. Let us look at it here. I just finished explaining table, rows and columns. To enhance data integrity, you must ensure entity integrity. And what is this entity? The rows. So you have to ensure that there are no duplicate data there. Yes, you have to ensure that there are no duplicate data there. You have to also ensure domain integrity. Domain integrity. So this ensures that it enforces valid entries for a given column by restricting the type, the format, or the range of value. So imagine this place is for name, this place is for salary, this place is for position. So this name means you can only put text data, which we call string. This means you can only put numerical data. It could be floating data. Floating data means number with decimal, or it could be integer without decimal. So it means this is salary, that has to be with number. And not just number, it has to do with a money-related number. So this is position. This position, you can't just put in anything. That's what we call enum. So enum is just a predefined number, predefined information, text or number that you need to select. So if you put in anything outside what is in the enum, it will reject it. And that's what we call domain integrity. If you come here and put in text, it will reject it, it won't go. That's what we call domain integrity. If you come in and put in number, it will not go because somebody's name is not number. That's what we call domain integrity. And this is what we call enforcing business rules. When a website is being designed, this is where a data analyst needs, or business intelligence professional needs to be there to ensure that business rules are being enforced by software developers. And they, of course, business analysts will definitely ensure that by software developers. They will tell you, when you're designing this database, ensure that the input is this. In your development, ensure that the input is this and it cannot be that. And when you give us another thing, it will reject it. It will throw an error. And you will tell it the error it will throw. So that's what we call domain integrity. Again, I will take it. Roles, the data you enter inside your roles are entity integrity. They enforce in ensuring that the right data is input in the right format and in the right format and data type. It's called domain integrity. So here ensures that the right data and no duplicate data. Here ensures that the right data format and the data type is being enforced. And this is also part of what we call business rules. Is being enforced when you are imputing data. Please take note, and this is called domain integrity. So another thing about data integrity is what we call referential integrity. So referential integrity means rows cannot be deleted when they are being used in another table by other records.
Come again.
So rows cannot be deleted when they are being used in another record. So the tables, relational database, enforces this concept of relationship among tables. Relationship among tables. So the customer data, we need to speak with the sales. The customer table, we need to speak with the sales table. It will need to speak with the employee table. So that, for instance, you need to know the employee the staff that you map to a particular customer. Like when we talk about a manager who is managing your bank account. And it needs to customer data also need to be mapped to the sales data so that you know the customer that did a particular, place a particular order, or the sales you have made through a particular customer. So you cannot just go and, delete any data, a data that is in one table and it's referencing another table. A row that is referencing another table in another row shouldn't just be deleted. It needs to be intact. So referential integrity is a logical dependency of a foreign key on a primary key, which you are going to also learn. I just hope we have time. We just have 1 hour to end the class. So referential integrity is the logical dependency of a foreign key on a primary key. The integrity of a row that contains a foreign key depends on the integrity of the row that it references. The row that contains the matching primary, that is the row that contains the matching primary key. All right, so Here is a customer data. So I'm going to use those two columns. Customer ID and name. So this is Fatima. Fatima, your ID is 1, or I'll call it C1. Your ID is C2. Chidi, your ID is C3. Right. So, but this is the order table. In this table, this is called the primary key. All right, so I'll put it by the side. We'll call it PK, primary key. But when this your data comes in here, all right, so this is the order table, and this is name. This is a customer ID. This is a sale order ID. Maybe this is your sales. So Fatima, who is C1, it is order ID, isn't it? So place like two order. Okay, sorry, the order ID is, let me call it 2. Let me call it 2. And here, that amounts to 11K. Fatima again, in another row, or let me put it to the row 3. Before Fatima, let me look for another person. Chidi, place this order, and Chidi placed 9 order, and this amounted to 60K. Fatima again placed another order, which is 17, and which amounted to like 100K. Referential integrity means don't go and delete Fatima's name from here. It will affect Fatima's record here. Does this make sense, Fatima?
Okay.
Yes. So don't delete it here. It's going to affect, we won't be able to trace who the customer is. It's going to affect all the records here. That's what referential integrity is. Because here, this customer ID is a primary key here. But when it is in another table, it is a foreign key. All right. So let's move on. Another data integrity term in another data integrity is user-defined integrity. All right. So I will explain this all over again, but let me finish the user-defined integrity. So user-defined integrity. So this I have already explained this before, but I explained it when I did the domain integrity. So this enforces some specific business rules that do not fall into entity, domain, or referential integrity. And I explained that. So we want things like a name to just be string, salary to be number, and position to be enum. You just need to ensure that this thing remains the way we just put it. So the database professional who is going to build database will need to enforce these rules. The software developer in the front end and on the back end will also need to enforce this rule when they are collecting data with the front-facing application. That is user-defined integrity. Now, again, data integrity ensures that these things are upheld. Entity integrity, domain integrity, referential integrity, user-defined integrity are enforced. Entity integrity ensures that there is no duplicate data. Domain integrity ensures that things like data types and data formats are being upheld. Referential integrity means, please do not delete data. Again, I will give you a more professional. So it's a logical dependency. So what it means is this data here depends on the original non-duplicate data here. So this is the primary key. This customer information here depends on this. So I'll map it like this. Customer data is here. And in this type of data, which we call dimension, you don't duplicate the data. It's just one customer at a time. It's just one customer at a time. So, and now you have a lot of it duplicated there because, say you go to place order in a shopping mall or in an e-commerce site, you can actually place order today, tomorrow you come and place order. Your name will remain the same, but your order ID will keep changing because these are different orders. But in the database, in the company's data and customer data, you are just one person. So we can't just go and delete your name here because you have a lot of record that will affect all the record on the transactional data. This is called the transactional data, this order transactional table. This order table is called the transactional table. So when you delete Fatima's name here, all these records where Fatima made orders will be affected. And you don't want them to be affected. Or perhaps they could even disappear. So you don't want them. This depends on this. So that is it about data integrity. Any question on that? Any questions so far, guys? ABS, please go ahead.
If that order table is called the transactional table, that sales table is called what? Or the customer table?
This is called transactional table or
Yeah.
facts table.
Okay.
This is called dimension. Dimensional table. Of it. Is it clear?
Yeah, thank you.
All right. Any other question? All right, guys. 5 minutes break. Our break has started.
I wanted to ask him all this integrity stuff. They are the one that they are considered the business rules or just the first two. We
I
noticed
think
the data
wait,
integrity, domain
Ruth,
integrity. Yeah.
please. All right. Can you ask your question a little bit far from your mic, then ask your question?
Okay, can you hear me now?
Yes.
I was asking if the data integrity, domain integrity, referential integrity, and user realistic integrity, whether they all constitute the business rule or just the first two that you mentioned. I noticed you talked about the business rule after you defined the first two before you went on to referential and next
Okay.
one.
So this is business. The business rule is actually user-defined data integrity. User-defined integrity. You are the user of this database or this data. You define how you want it to be to ensure that the business rule is being enforced. User-defined integrity is the additional integrity to check for your data. So let's say the testers want to check for the database you're building. In your user story, they could see that this database should have name. The database should have name, salary, and position. And in this column, the only thing that should come to name should be a text. It should be numbers, and this should be text that's predefined text. So the testers will come and check whether is there any column. They can just write a query, all select all rows where the name is not a text, or where the salary is not number. And if it pushes it out, that means your database has failed. Your table has failed the test. You need to go and rebuild you need to go and enforce this integrity in your table design. That's one way the data analysts, the software testers, or yes, quality assurance engineers will test tables and databases. They just want to be sure that what you said is there is actually there. They can also test, please take note, they can also test entity integrity, domain integrity, referential integrity, and user integrity. These things are very important and very popular things that you are going to be testing out there as a software, as a QA analyst. And as a data analyst, it is your duty to ensure that these things are in order. All right, so the business rule here is this, just user-defined integrity, if that makes sense.
Okay.
All right, so if there's no other question, we will go on 5 minutes break and we will return. 5 minutes, we will return at, all right, so I'll just make it 10 minutes so that you can drink water before you say you did not even drop the cup after drinking water. 22:23, we will return. Time starts now.
Thank you.
You're welcome. You're not. So these are what you're learning now is foundational terms in SQL. Database normalization. Database normalization. The method or the process in which you use to organize your data in your database is called database normalization. So it includes creating tables and establishing relationship between those tables. So now, according to the rules designed both to protect the data and to make data more flexible by eliminating redundancy. So what really happens here is we had a table called customer table. Then we have another table called the order table. So customer table, no, I think I need to go back there. This, for me to implement database normalization here, I need to do something. Here, I have customer name. I also have customer name. I don't need this here because it's already here. So the process of ensuring that we do not repeat ourselves on two tables, having the same record on two tables, it's called database, it's called removing redundancy. So database normalization helps us to remove redundant data. Now we have stored this here. All we needed to do to reference Fatima, Elo, or Chidi on this customer table is just this foreign key here. This foreign key, I can use it to say, I want to select all the data from here and all the data from here. So what it will do is it will look at the customer key here, a primary key here, which is the customer ID, and say, okay, there's also another customer ID somewhere here. So to match this person who has this sales and this order, who we don't know their name, but we know their ID, let's go to the customer table and fetch the person's name. Fetch the person, already the person's ID is here. Just fetch the person's name, match it to the ID that is there, then we'll be able to know who actually had these wonderful orders. That is it about redundancy. That's what data normalization does. So in the course of testing QAs, you come to a table. That table has a name. That table has a name and is a sales table, an order table. And then it goes to another place. It still has that same information, name, which also is the same from this other table. You will need to tell that you need to ensure that you normalize your data and implement database normalization. Remove redundant data. Remove redundant data. So eliminating redundant data, for example, storing the same data in more than one table is what we call redundant data. And that's what database normalization does. It also ensures dependencies. It ensures dependencies makes sense. So why this data is dependent on the customer. The full name of these persons who are doing this transaction is dependent on the customer table. It makes it make sense, actually. And the relationship makes everything interesting. And this is the power of data normalization. So normalization reduces the amount of space a database consumes. Imagine you have this column name here, this column for names, and you still have it here. That is a waste of space, because for everything you put in there, it takes space in memory. So you remove this one. Since we have this, it's going to reference everything here, and you have preserved all the space, or this column, the space you would have wasted. Like I said, it also ensure that the data is logically stored. So normalization consists of a series of guidelines that helps us in creating good database structure. So normalization guidelines are divided into two forms. Normalization guidelines are divided into two forms, which is a way database is laid out. So the aim of a normal form is to organize the database structure so that it complies with the rules of first normal form. So I'm going to explain to you what these forms are. Explain to you what these forms are. So normal form is our choice to take it. Let me get here, explain it better. I am worried here because if I start explaining this, I'm going to lose everyone. So I'm going to pause on the levels of normal form, and I will move on to another thing. We will map out a particular 30 minutes or 20 minutes to explain these concepts, maybe through tests, or I'll have to make a video about it. So please, let's move on. I don't want to create an issue on things that are already moving smoothly. All right, so understand the most important part of database normalization is to remove redundant data. This is the most important thing it does. And it makes this relationship thing between tables make sense. That's the most important thing this database normalization does. So when you're building tables, you notice that earlier I talked about data types. And some of the data types I talked about are floats, the integers, which are numerical data types. I talked about string like text. I talked about enum. So these are data types. And this is a way your database understands what is categorical data, what is numerical data or quantitative data. And those things, categorical data are just data that are, that you cannot calculate. Things like your street name or the name of a person, things like your state. These are categorical data. These things give meaning to your quantitative data. Whereas your quantitative data are the ones you can calculate, like age, sales. So being able to, the database, SQL's way of understanding what you meant, whether data is quantitative, whether it's numerical, text, dates, time, or understanding the kind of data you're feeding it or it should take from you is what we call data type. Data types are important in every programming language. Data type. Please take this serious. All right. So in SQL, we have a few data types that you will be using. And we have the big int, that the big integer. I will give you an assignment to read up on SQL data type. Read up on SQL data type. But I'll explain as much as I can here. So we have the big int. But in this case, take it as integer more than this. This is just, I'm going to take more numbers. I can accept more numbers, more strings of more levels of numbers. That's what big int means. We also have normal in that int itself, which does not take as much as big int. And int means integer, the normal number you talk about. Just normal number you talked about. Small int takes fewer number. But at this level where you are, you should concentrate your mind on int. Forget about whether it is small or big. Put your attention to int. But you need to know that such a thing exists so that you don't go there. So which one is small int and big int? All right, so we also have tiny ints. So fix your mind on int. So far, I have only said one data type, which is int, integers. Then next one is we have decimals. You know, decimals. We also have floats. We also have floats. And the question is, what is the difference between floats and decimals? Can somebody help us then? I need help, guys.
I think floats. I
Yes.
don't know if it's I don't know if it's something with like if your float can contain let's say a very big decimal when you have like well decimal may be what like one I don't know I don't know the right word to actually explain it, but float and decimal they're almost the same thing. So it's
Okay.
just that float might contain a bigger data compared to decimal.
Yeah, that's actually spot on. So the thing about decimal is it could just say 2.37. But when you talk about float stores approximate values. So a decimal, a fixed precision data type that stores exact value. It stores exact value, but float stores approximate value. And it's more. So this could be, so you know, in mathematics, pi is equal to 3.142. Decimal can store it as 3.1. Float will go ahead to store it as 3.142. Actually, this is not where it ends. It's a recurring decimal, so it will keep recurring 3.142. It will just keep recurring. After getting to 42, it starts again. It starts all over again. But that's not the story for now. So this is more, this is less. But What's your business about it? Just use any one and do your job. It's not going to affect what you're doing. But understand that when you're dealing with money, this little decimal or this little thing makes sense. They make a huge difference. So please ensure that. So what I mean is, I'm going to bring out my calculator now. You see the calculator?
No.
You cannot see the calculator.
No.
All right, so my whiteboard has disappeared. So that 3.142 means if I have for the float, I added 142. I added the 42. So let's calculate what 0.0, because that is the 42. This is what I added on the float side. Raise it to the power of, where do I get my raise to the power? I don't know where it is. All right, scientific calculator, good. 0.042. If you're actually ignoring it, I'm trying to give you the difference. So if you do 0.042 and raise it to the power of 100, that is 100%. This is the amount you will be ignoring. This is the amount you will be wiping out. All right. So this is the amount you will be wiping out. So ignoring all these things is not important. It's not good. And if this is money, somebody will say, this bank is stealing my money. If you're doing a sales transaction, you will be. So you end up having some errors somewhere. So when it has to do with money, maybe you should consider, rounding off at the last display or the last value. That's when you can consider rounding up. Please don't round up on the way when you're doing your analysis. All right, so all right, I still have my stuff here. So we have float. Don't worry, I will soon round up. You can see that SQL is much. We have money. We have date time. So date time is different from dates. This gives you the date and the time, but date format is different. So please take note of what you're looking for. This gives you dates and time. This gives you only dates. Please take note of the two of them. So most times in the world of data, we make use of date time over dates. So please take note of this. Not most times in IT, we make use of date time over dates. Please take note of it. I'm not saying I prefer this over this, but it depends on the situation you're working on. So please take note of that. All right, so that's it about numerical and date data type. But we also have the main one you use all the time. We have the character. So we just talked about numerical. We talked about date. Then we have like character data type. So the character data type, we have the varchar. This stands for variable character. Anything, you can put anything. That's what it means. Then of course you have the normal character, which is just text. And you also have tests, which means I can take more information. So this have like limited numbers they take. This is used to take more information, tests. So maximum number of length is so much. So the maximum number of length for here is like 8,000 characters. But for this one, it's so much. It's so much. Please take note of that. All right, so this is it for this level. Any question? Because the next one we're going into is going into commands, which I will not start now. I will only start it with. Any question here? I will only start it when we start querying data. Any questions here? Guys, ask your questions, please. People waiting for SQL. SQL is here and you don't have questions. Sense, you got no question?
No questions.
Ruth, all right, Vincent, you've done it. You have been asking questions here. You and ABS. So I'll go to Blessing, Chidi, Elo, Fatima. Fatima actually asked one, I think. Josh, question time, Kenny, Casey. Question time before I move out of this.
I mean, I'm here. Honestly, I don't have question. Maybe because I've done SQL before. Yeah, but I don't have question.
All right, excellent. Who else, please? Do you have any questions? All right, so I take it that there's no question. I take it that there is no question. Hooray, we are on SSMS. Just a few minutes, we are done. This is called SQL Server Management Studio, SSMS. All you need to do is go here on your window, you type SSMS, and it will come up. You click here, and it will open. I already have it. If I want Workbench, I will come here, Workbench. So this is my Workbench. You can say it, my SQL Workbench. I will open it. My system is not a very strong system, but I'm just gonna try and open only two of them. So this is the interface of Workbench. I have just one instance. One instance means one type, one instance means one type of the data. I can create multiple of them. Like I can create two Workbench working together. So I have one instance here for my database. So when I click on it, it opens. I've not opened it in ages anyway, just for the sake of this program. So I clicked on that instance, it opens. And when it opens, this is what you see. My SQL is very intuitive, easier than SQL Server and SSMS anyway. It's very intuitive. Please take note of this. So please take note of what I'm explaining. It's for everyone, whether you installed it or not. I'm going to explain the both interfaces. I'm going to explain the both interface. Please take note. So, because you don't know what you're going to see at work. This is my SQL. This is my SQL workbench, my SQL workbench. So on this, at the top ribbon, you will see home whenever you want to return home. Here you will see the first instance I open. If I click on this home, it takes me back to where I started. It takes me back to where I started. Can everyone see the screen, guys?
Yes,
Yeah,
you can see it.
yes.
All right. So when I click on this home, it takes me back to where I started here. Take note that this is also open. My instance is also open. And this is it. So I could actually open another instance here. So you can see I've opened two instances. Look at them. This is the other one. Okay, I will type on one. I will type on one. Select all from. All right, so let me do something. Let me open one table. Select all from actor. Select all from actor. And we run it. All right, so it's not seeing what I am. So I will run this. I will click it here. I've selected it. I will run this. So it has selected everything from actor. You can see my table run. I just ran the first SQL query, and that's how simple it is. Okay, so when you install data, okay, I am on this interface. This is the other instance I opened. But I hope my system is not hanging now. Okay, this is the other instance. Nothing is here. This is this instance. So I can come here and this X and I will delete that instance. No, delete it. Good. I've deleted it. So it brought me to home. I can still go back here. So let's go back to that home. I've explained what this is. If you want to create another local instance, you can come here and create another MySQL instance, maybe with different password and all those things. You can create it. This is the database side. This is the model side. So the model is the relationship side in a table. If I want to get the relationship for this SQL database, it is here. So it's opening right now. And this is the model. So this is the model. I will click on the diagram here so that you will see how it is. All right, it's open. This is how it looks like. And we are going to do this. Please
No, because my patient.
mute yourself. All right, so we are going to actually create this. All right, so let's move on. It just opened the diagram for us, and you have seen the relationship we're talking about. It's so amazing. All right, so I'm going to leave this diagram. I'll click here. All right, so I'm back to table. Remember, if I want to go back there, I am here. So I'm back to this place. This is my SQL interface, very intuitive. Actually, learning SQL here is simpler than learning SQL in SQL Server. But SQL Server is the industry standard. That's why we're still going to be using it, or we'll be using it more. So by this side here, you see schema written here. This schema is just the name of your table. So this, sorry, names of your databases, and these are your databases you're seeing there. So it has secure, that's a sample database for you. It has a sample database that has different, it's about a movie database. It has different data you can actually start working with. You have system database here. So this is system database. Sys database. We also have another database here, about world database. These are, so when you install MySQL Workbench, it comes with this data sets for you. Now, these are the databases for you. When you create a new database, it comes here to stay, and it's very intuitive, very easy to create. Now, I finished explaining this. This is file. When you click on file, you will see so many things you can do. New model, you want to start drawing the model, the entity relationship diagram I showed you. You can create a new query tab. If I click here to give me a new tab, see the one we were working with before. This is this one here. All right, so open model. If I want to open any model, I can click here and open that model. When I click on it, it will take me, okay, it will take me to where I save the model and I'll bring it up and open. And so all you need to do is to try most of these things that are here. So, and when you look at this, these things that you can execute by your click also has shortcuts here. Control N, Control N, Control T, Control O, Control Shift O for you to, for those who are shortcut people. You can go here. So we have edits. Of course, you can see all the normal undo, redo. So if I go to where I have file, good, I have typed something, you'll be able, edit will make more sense. So I can undo. If I copy this, if I highlight this, and you can see cut and copy comes up. If I actually copy it, and I go there, paste comes up, delete comes up, select all these things come up. And find, you want to find, format, you want to format. So if you want to beautify your query, if I click on beautify, you will see what will happen to my query. You see how it did it, what it did to it. This is what it did to it. It moved from here. It moved from here to here. That's what that beautify does. It makes your code look cleaner and readable. That's what it does. All right, so let's continue, guys. Hide, floats. All right, so if we go to view, so view home, there we don't have much on view. Query, you want to execute all, execute all or selection. So these things are things we do. So for instance, if I want to, let me explain this to you with tables here. I want to also write another code here. I'll just copy this, paste it here. But this time I will close this. This syntaxes, I will explain those to you. I want to query all the address. All right, the IntelliSense has. All right, so I'll close it here. Now there are two distances. If I run the both of them together, one will run okay, without selecting anything, if I run, one will run after the other. All right, so this one has finished running, the other one has run. You can see them there. And if you want to see if you want to see the first one that run, all you need to do is to come here. You can see actors. You can see it here. If you want to see address, you can see here. These are the tabs. They are saved here. But in case I want to run only one, if I want to run the one on, I just need to highlight it and run it here. So what is showing that execute the selected portion of the script. I will then execute it. So it will only execute just this one I selected, and that's what it gave to me. And that's how you get to write multiple queries on a script and use it to even debug. You can write like 500 lines of code, SQL query, and you highlight them one at a time to actually understand what is happening in your code. All right, so that is it for this one. And this one is, so I want to execute only this. If I put my mouse here without highlighting, without selecting, I'll just keep my mouse here. I can come here, click here, and it will only query, it will only run the first one because it says execute the statement under the keyboard cursor. And when I run it, it will just run that one. Understand it? Put your cursor at the end of it, or the end of any query, and run that query, or highlight that particular query and run it with this one. That will do the job. Okay, so we have that's it about queries. So here, database, you can connect to database, manage connection, reverse engineering, which I will encourage you to go and learn what reverse engineering means. It means just solving your problem backwards. All right, schema transfer wizard, migration wizard, if you want to migrate data. All right, so don't know what is happening to Elo. She keeps logging out. I don't understand the network today for her. All right, so this is just the interface. Now, my time is up. All right, so I'll just go here and so this is a script. All right, so I'll click here. When I click here, it opens a query interface for you and another query tab for you. If you click here, you save a particular query. So this one we have run, I want to save it. You can see it's written query 1, but I want to save it. So I'll come here. Oh no, so this one here, if you want to bring in an SQL query, you click on it, it takes you to where the SQL code is. SQL file is, you import it, and it will save there. And it will run here and produce the table. All right, so, but the database should have been open here. Otherwise, that SQL code should actually have a database in it, a query that will create a database for you. All right, so create a new schema in the connected server. In this connected server, I can create a new schema here and open inspector for selected objects. This one, we don't have business with this. So you can create a table. You can create a new view in it. This is table, this is view, this is stored procedure, and we are going to do all of them. If you have a data here and you want to save it in, maybe export your data, all you need to do is come here, export data. So I can come here and export my data, and I will export it as CSV. So it has different format anyway, but I will export it as CSV. And when I export it, I will call it actors. And I will save it on my desktop. I'll have to delete it from there. Save it. So it's a CSV file. If I want, I can go to, all right, so I'll open it from File Explorer. I'll go to my desktop, and this is actor that I saved now. And when I open it, you can see the data set all there. Opening, I'm waiting for you to finish opening. All right, you can see the data. Data is here that I just saved. And how many rows? That is 201 rows. All right, so I will close it. No, I don't want to save it. All right, so this is about this. And for now, this is all you need to know for this one. And we will, of course, during the course of learning SQL, we will come back here and we will be running queries from here. So I will quickly run an overview on SQL Server. So I will bring down this. So this is the one most of us have, and this is the interface that will always come when you open it. So in this one, this is SQL Server Management Studio, SSMS. So because you are connecting to database engine, you should leave here as database engine. you don't have business with analysis service, I'm sure in some job you would have seen some things they will tell you. You need to have a knowledge of analysis service, that is SSAS, SQL Server Analysis Service. Another one is SQL Server Reporting Service, SSRS. The other one is SQL Server Integration Service, SSIS. These are the core, the 1, 2, 3, 4, 5 make up what we call Microsoft Business Intelligence technology or tools. These 5 technology make up the Microsoft BI tools. So when you're applying for business intelligence position, you need to know how to use all of them. All right, so that's because we're working with only SSMS, we are going to leave it at database engine because it's database we're working with. This is your name. This is your name. This thing you're seeing is your name. If you don't have this, all you need to do is open your command prompt. Go to the window, type CMD, then it will open command prompt for you. So you can see the command prompt here. Are you seeing my command prompt open?
Yeah.
Don't be tired, guys. I'm almost done. So this is command 1. If I want to know the name, my name here, since it's not here, I will type, who am I? So you can see, this is my name here. Desktop, this, Kings. That's my name on this computer. But real the Kings is the account, the name I created. But this other one is my computer name. So I could actually change it to, I also have others, SQL Express and the Kings. I could change it to them, but I would stay with real the Kings. So it is recommended that you use Windows authentication. Windows authentication. It is recommended that you use it whenever you are connecting to SQL Server. It is much more secure. And I will click on connect. And here I have been able to successfully connect to SQL Server. And that is where we will end the class for today. We are not able to continue.